Okay, so this is your review for the upcoming test, or what to know. So we're going to start with just kind of the basic things. You need to know how to do a right-hand Riemann sum, left-hand Riemann sum, trapezoidal sum, and the midpoint rule. Remember, we didn't do much with the midpoints. It's mostly going to be left, right, and trap, but midpoint is possible. I won't ask you to do more than probably 4 rectangles or 4 intervals, so don't worry about it. You will not have a calculator, but it shouldn't be too taxing. You have to be able to tell when something's going to be when one of those approximations, either 1, 2, or 3 above, is an over or under estimate. Remember, if the function's increasing all the time or decreasing all the time, then you can tell whether the right or left-hand Riemann sum will be too big or too small. And the trapezoid had to do with concavity and whether it's concave up or concave down. So we'll do that. Let's see. I just draw a sketch, and I think it'll be pretty obvious. Okay. You have to know how to use a table, finding approximate integral from a table, or using a function. You have to know those 5 properties that we had on video quiz 1. So just look back to video quiz 1. There was 5 properties, and you need to know those of integrals. You have to know basically when to look at an integral as an area. When can you view it as an area? You can always view it as an area as long as you understand is it positive or is it negative, but we went over that. You have to be able to use unit analysis to interpret an integral, and we did that to understand what it represents. Okay, here's our first problem, just for practice. So I've drawn a sketch. 1, 5, 8, and 1, those represent actual areas. Those are actual areas. And the question is, what is the integral from a to e of g of x dx? So you can pause it now, go ahead and do it, or whatever, I don't care. You can probably figure it out by now. So most of you already have figured out that it is, I can't add this, 1 minus 5 negative 4, 3. It comes out to be 3. Oh, there we go. It's 1 minus 5 plus 8 minus 1 equals 3. Remember, 5 is below the x-axis, 1 is below the x-axis, so those are negative. What about the integral from d to a of g of x dx? The integral from d to a of g of x dx. A couple different ways of doing it. Go ahead and give it a shot. Pause the video. I like to do it this way. Hey, Miss Dodd, how you doing? I do the opposite of the integral from a to d of g of x dx, and then I do it exactly the same way we just did. So we're looking at the opposite of 1 minus 5 plus 8, and assuming that I can add, that is negative 4. Okay. Now we're going to look at the same graph, only now we're just going to interpret it as an actual problem. So this is a graph of now velocity versus time, and I'm going to ask some different questions. Okay. Our particle is going to be moving left and right. Remember, it either moves up and down or left and right. Okay. So when the velocity is positive, it's moving to the right. When the velocity is negative, it's moving to the left. We started at the point 313, describe the position of the particle. So what happens? Does it move left or right? How far and until when? And then what happens? Okay, so just go ahead and talk about that. Write it down. Pause the video. I could waste time just sitting here talking, but maybe you want me to sing. No, you don't. Well, it starts at 313, and then it's going to move to the right 1 unit, 413. And then it's going to move to the left 5 units and end up at negative 113. Then it's going to move to the right 8 units, ends up at 713, and then it moves to the left 1 unit, 613. So we would say that it ended up, its displacement, it started at 313 and ended up at 613, so the displacement is 3 units, 3 whatever. The distance traveled is, what, 5, 6, 14, 15. I think that's right. 5, 6, 7, 15, yes. Now we're going to do an integral graphic, well, not graphically, one where you have to create the graph. So we're going to go from negative 3 to 5 of that thing there. Now it's possible to graph that all at once, and it would create basically trapezoids, but it's a little bit more work than I want to do. Actually, it's a lot more work than I want to do. So I'm going to, first of all, split it up. I'm going to split it up into one simple function, 3x minus 6, and another simple function, absolute value of x minus 1, and I'll do them separately and then add them. That's using one of the properties. So now we have to graph 3x minus 6 from negative 3 to 5. And now I just need to make sure I did this correctly. So when x is negative 3, that's negative 15, so that looks good. When x is 5, that's 15 minus 6, which is 9. That looks good. So now I have two triangles. Well, this is simple. Triangle A is going to have a negative value. B is going to have a positive value. So it's 1/2. The height is 15. I guess I kind of did this backwards. And the base is 5. Because the right hand, it intersects the x-axis at 2, 0. And then the left-hand endpoint is negative 3. And from negative 3 to 2, that's 5. And then we have to do B. Oops. That's 1/2 of 3. The 3 comes from 5 minus 2 times 9. Now remember, the A part is going to be negative. That's negative 75 halves. And the B part is 27 halves. And if I can add correctly, which very well I could have gotten wrong, but we'll assume I did, it's negative 24. If I didn't, feel free to correct me, but so that's just that part. Now we got to do the absolute value part. Well, that's actually a little bit easier because when x is 5, that's 4. When x is negative 3, that's 4. So I basically just get two triangles. In fact, two isosceles triangles. I could put it together and get a square, but that basically has an area of 16. So now I have to add that to the negative 24, and I get negative 8. I checked in Mathematica, so it is right. Now we're going to take a table, left-hand Riemann sum with a table. Now be careful, because the first thing you notice is that these delta x's are not all equal. So left-hand Riemann sum, you remember what height it starts from? That's right, the 3. So it's going to be 3 times, hope it's 0.1. Hope I didn't mess it up. And then 5 times 0.2, and then 2 times 0.3, and then 4 times 0.2. I actually wrote those all down and I just stopped. Okay, that's it. Right-hand Riemann sum is going to start at 5. So basically I'm just going to I'm going to get rid of the 3, put the 5 in, get rid of the 2 and put it in the 5 spot, move the 4 to the 2 spot, and then bring in the 7. Everything else stays the same. Trap, average left and right. Mid, can't do the mid. They're not equal length subintervals. You cannot do the mid unless two things are true. Number one, they have to be all equally length subintervals. Well, is that true? I guess technically speaking, you could get by, but don't do it unless they're equally spaced. There's things you could do, but we're not going to. And then you need an odd number of data points, which we do have, but we don't have the other part. Okay, now we're going to use an approximated integral using 8 rectangles. I'm just going to write this out, by the way, with, let's see, I'll give you some time. You should just pause the video. That's why I'm pausing here. Go ahead and do it. We're coming upon 15 minutes. This is getting really long. I want to finish before 15 minutes. Okay, so there it is, 5 minus 1 over 8. So it's b minus a over n. And then I just put the values in. Square root of 1 plus 1.5, 1 plus 2, 1 plus 2.5. Because remember, this is a, this is not a Riemann, I'm sorry, this is a right-hand Riemann sum. That's what it is, right-hand Riemann sum. Just leave it like that, I don't care. Okay, this is the hardest problem, save the best for the last. This is actually a pretty cool problem. These are line segments, and that is a semicircle. And our goal, one job, to find the integral from 5 to negative 4 of h of x dx. So what do you want to do first? I know what I want to do first. That's right. I want to flip it to be the integral, the opposite of the integral from negative 4 to 5 of h of x dx. And then I'm going to just use some geometry. It's all geometry. There's no calculus in this. You just have to understand what you're looking for is the area. So to speak. So realize that the value of A, we're going to find the area, see that A up there? We're going to find the area of A, and then the area of B, and then C, and then D, and then we're just going to do what we need to do to add them together. So for A, that's a triangle. Well, I need to find the x-intercept so I can find the area of that triangle. Okay, so the slope of that line is, I hope, 5/4. You got 2 points there. You got 0, 3, and negative 4, negative 2. So the slope is 5/4. So that's going to allow me to find the x value. So I'm going to do slope is 5 over 4 is 3 over x, because that's the other thingamajig there. So x is, well, okay, x is actually negative 12/5, but I don't really need that. So anyways, I understand it's negative 12/5, and so I think you'll be okay with that. So again, really negative, but I'm not really interested in that. So the area of that triangle for A is 1/2. Well, the distance from that x-intercept to negative 4 is just 4 minus 12/5. Again, I'm just doing this as area, so I'm finding that length. The height is 4. Half of that is 16/5. So that's the area of region A. Now I'm going to do the area of region B. Well, this is easier because I found that to be 12/5 already. So that is just 1/2 of 3, which is the height times 12/5. I know it is a trapezoid. I could have done it that way, but this is just easier. C is a rectangle. Can deal with that. 2 by 3. Okay. D. That is a little bit more of a, hey, how you doing, Miss Wheeler? You want to say hi to my students?
Oh, hi. Are you talking to them?
Yes.
Right now?
Right now.
Hello, students.
Although it's interesting that my video seems to have started over.
Huh.
That would be interesting. Darn it.
I
Okay.
got a section people.
Okay. So I lost my train of thought. Oh, okay. So I'm going to, well, you figure out how you're going to plan out to get area D. And I'm going to do it the way I would do it. So I would draw a little rectangle around that. That's a 3 by 3 rectangle, or square actually. And I would subtract the quarter of a circle that is. 1/4 pi r squared. Pretty slick, huh? So 9 minus 9/4 pi. So now I've got all my 4 values that I needed. I got A, B, C, and D. I realize that B, C, and D are all positive, but A is negative. And so now the integral from 5 to negative 4 h of x dx is going to be the opposite of all of these negative 4 to 5, which is what I just did. So it's negative 16/5 plus 18/5 plus 6 plus 9 minus 9/4. And all that simplifies to 9/4 pi minus 27/5. And my hope is that's correct. Oh, yeah, it is. It's negative. It should be negative. And that's the end. So have a good day.